Oh, yeah. Act like I don't see this. Okay. Okay. How many nitrogens would balance out iron?
4.
How you figure 4? Did not tell you, Michelle. Act like you don't see this right here. Okay?
55.
Huh?
6 and 4.
So iron has a mass of 56. Nitrogen has a mass of 14. You divide them, you get 4.
I have a question.
Yeah.
How much leeway do you get with, because, like, I know in some instances it's not going to be the exact same weight to balance it out. You know, like, alright. Well, give one right now. Like, alright, PT, right?
Lord, look where he going, PT.
It's like 78, right?
Uh-huh.
Element 78. And like LR, right? Which is like element 103, right?
Well, why are you going so far?
But look, if 2 PTs is like more than the 103, but 1 PT too little.
So why would you try to balance them out though? Anybody balancing PT and LR?
Oh, so I know, so you go.
No.
Okay.
It no gusto. Right? How many carbons would balance out 6 heliums?
2 carbon.
Oh, helium?
How many carbons will balance out 6 heliums? 3.
1.
1.
Helium is 6 helium.
2.
1.
1. 2.
How many carbons balance out 3 heliums?
Well, you know what 6.
Oh, they said, you know.
Maybe I need your eyes to get checked.
Oh, 2.
Okay? 2. Okay? 6 helium is 24 AMUs. That carbon is 12 AMUs, so it needs 2 carbons to balance it out. How many calciums will balance out argon? 1. Do we get that? You good? Right.
Did you see her?
Okay? No? Who said no? I heard it. Yes. Wow. Okay. What's the mass of helium? 4. See that? How many would 6 heliums be? 24. What is the mass of carbon? 12. How many of those 12s?
Oh, 12 of me too.
Alright, good. Alright. Are we good? Any questions, comments? What time do we have? 12 o'clock?
30 minutes. 30 minutes.
Yeah, tons of time. Tons of time. Alright. Atomic weights and isotopes. Alright?
This is not here at all.
They don't give you enough examples.
Okay.
So I have to add examples in there to what I think you will be comfortable understanding what's necessary. And I do that with a lot of chapters, which is why my chapters are significantly longer than what you have. My example, my lectures are jam-packed with examples so that we can practice in class. Okay? So your atomic weight will now, where does your atomic weight come from?
Number of protons.
The number of protons and number of neutrons. So now, if you take into consideration isotopes, what's going to happen? Remember, your isotopes are different what? You got different number of neutrons. So now, your isotopes are going to play a part in what your atomic number is going to, your atomic mass is going to be, right? So, for example, here, naturally occurring phosphorus contains 15 protons and 16 neutrons and has a mass number of, its isotope is 31, right? So this is your isotope symbol. Phosphorus has 1 isotope. So what is the percentage that this isotope will
isotope phosphorus, how much of a role it will play towards the mass.
Uh-huh.
And it's one isotope of phosphorus
Uh-huh.
compared to what's the other isotope?
No, and no other isotope, you're talking about phosphorus.
Very, very minimal. Wait, no, it's everything then. Wait, time out, no. Is it phosphorus and another isotope?
No, I'm telling you, phosphorus
By itself.
by itself.
It's everything.
You sure it's everything?
How it can't be nothing else.
I don't know, you tell me.
It's phosphorus. Phosphorus is phosphorus.
Phosphorus is phosphorus.
Yeah, it's 100%.
Right? 100%. Good. All right? Every isotope in your atom will have a certain percentage that it plays for your entire mass. If you have phosphorus that has only one type of isotope, what is the percentage that it plays in 100%? Okay? Carbon and hydrogen, they both have 3 different isotopes. But the percentage of their isotope is different.
It's not going to be like all equal.
No, it's not all equal. Okay? Let's bring it home. All right? Let's say, Tatiana, you got mom, you got dad, you got your little sister, your little brother. Okay? Dad has a full-time job. Mama has a part-time job. All the kiddies ain't got no job. Bunch of leeches. Okay? So, in terms of the bills, who is going to partake most in paying the bills? Dad got a full-time job. Mama gonna pay some of them. Kiddies ain't got nothing. Okay? This is what your isotopes, this is what how your isotopes are going to behave. Okay? So here, you can figure out the atomic weight of your atom just by knowing the abundance of your isotope. That means how much of your isotope is, how much of one particular isotope is present. Alright? Here, for example, carbon. Carbon has the 3 isotopes. Carbon 12. 98.89% of carbon is the isotope carbon 12 and has a mass of 12.00 U. Carbon 13 has an abundance of 1.11% and has a mass of 13.00335 U. Carbon 14 has 0% abundance and has a mass of 14.0 U. Just by these numbers, what can you tell me about the mass of carbon? Yes, don't tell me you don't know, you know. Think about it, put it together, link it together, and what you see in terms of mama, daddy, kiddies.
Carbon 12.
Carbon 12 what? No. Carbon 12, the mass is 12, that's known. But in terms of, remember, your atomic mass will be the sum of all of the isotopes, right? So based on what you see, the overall mass of carbon, how is it affected by the isotopes? Who's going to
The mass increase.
12. Carbon 12 is the most, no?
is the most? So then what?
He's daddy, basically.
He's daddy. He's going to be giving the most towards the mass.
I thought you said the mass is 12 for
The
carbon.
mass of carbon 12.
But then carbon 14 is 14.
Yeah.
It's a larger
0%,
mass.
but the percent you're looking
Look
at.
at the percent. The 0% comes from carbon 12. Carbon 14, sorry. That's the big-headed leeches that come here just to eat off stuff. Right? You got the 98.89% comes from carbon 12. So carbon 12 is taking the brunt of the mass. Carbon 13 takes a carbon 14 takes nothing. Okay? So now, how do we calculate based on the abundance? How do we now calculate what the atomic mass will be? We got this?
Yeah.
Oh gosh.
How you calculate the atomic mass?
Yes, how do you calculate what the atomic mass will be? Alright? So the first thing we do, we have, you're going to add up the amount provided by each isotope. Okay, I don't like to work with percentages, so I'm leaving my percentages as whole numbers. Okay? That's just how I do it. I don't want to work with 0.9889. I want to work with 98.89. Okay? That's just how I do it. Alright? So you have 98.89% times the mass. Right? You're going to now add that. You're going to add up each of your isotopes times their abundance. So you have 1.11% times 13.00335 U's plus 0% times 14 U's. All of this divided by 100 because you still need to get rid of that percent.
12.01.
Okay? So let's bring it down. What does this equal to? 98.89 times 12.
11 point,
No,
1186.
1186.68
Oh, I didn't put 2 zeros.
plus 3.33. No.
14 point.
You sure this looks up?
14.43. 14.43.
1.11 times 13. 14.43 plus 0 divided by 100. Add this up, what do you get?
You round off that 14 there? The
Yeah.
40, the 14.43 round
I don't know,
off?
that's what somebody told me.
Yeah, but it's a longer number, but do you round it there or you
No,
round it
right
at
at
the
the
end?
end.
Okay, so then it's 14.4337185.
Add them up. And technically you can work with significant figures here too. So come, keep going. What do we have?
1201.11.
1201.110.
113719. Do you round off now?
No. Did you divide by 100?
No, we haven't divided by 100 yet.
It's 120.
120.11.
11. Yeah, 3719.
Divided by 100. That gives us
12.01.
now how many significant figures do we need?
That is 2. So
1. Oh no, you by how many is after the decimal point? In total, so 1.
What they're asking, like,
4.
How many do you need?
4.
4.
Why 4 if you have
Because we have 12.0.
The original question.
12.00.
The original question gives you 12,
1.
right? So where do you cut off?
01. So 0.01.
You look at the neighbor,
It's less than 5.
less than 5, so you get 12.01 U's.
wait, the original question is asking what?
But why
Why is it 12? There's more than one number. Because
What do you mean?
Because it's the original carbon you're looking at?
Uh-huh.
Okay, so we find the we're using that one to show the significant. Okay.
Yes. So as compared to the atomic mass on the periodic table, your calculations and what does it say on the periodic table? 12.01. So again, you don't need the periodic table to calculate your atomic mass. All you need is the abundance. Alright? So let's try another one. Calculate the atomic weight of chlorine given that the naturally occurring element consists of 75.53% chlorine 35 that has a mass of 34.97 U's and 24.47% chlorine 37 which has a mass of 36.97 U's. Who's gonna do it for me? Okay.
So there's only 2 isotopes.
There's only 2 isotopes for chlorine.
It's okay if I erase. You take the abundance, which is 75.53% times the mass, which is 34.97 U's, plus the abundance per second, which is 24.47%. You said you don't do significant figures yet, right?
You keep everything.
Okay.
Oh, why do you divide by 100?
Because I don't like to work with
You
percentages.
have to remove percentages over there. To get rid of the.
So what is this in actual percent? Like the whole number? 0.7553.
Oh,
We're working with the whole percent number. So in order to get rid of that at the end, you divide it by 100.
yeah. Okay, so what's it?
You can do it in the beginning. That's fine.
My calculator has like a percent.
Okay.
Oh, okay.
Do you want me to write with and then the original has only 2. But
The original has how many?
no, I was just doing it.
You said the original only has 2.
Oh well, 2 after the decimal.
Oh, okay. Alright, good job.
I'm gonna get in trouble for these U's.
So what do we think?
Yeah, that's what I thought.
So we all got?
Yeah.
How does that compare to the atomic mass on the periodic table?
We round it up. We have 35.453.
Roughly the same thing,
Yeah.
right? Roughly the same thing. So now, here's another one. Fluorine consists of a single isotope, fluorine 19, with a mass of 19.00 U's. Determine the atomic weight of fluorine and compare your answer to the value given on the periodic table. Very good. Okay? We have 100% of this one isotope contributing to the mass. So the mass is therefore 19.00 U's. Alright, let's do another one. Magnesium has 3 isotopes, magnesium 24, 25, and 26. The relative masses and percent abundances are as follows. Calculate the atomic mass and compare that to the mass on the periodic table. Who wants to do it? You got it? Go. Erase that. You see my eyes right now. You don't need to write all of that. We got that right here though.
Okay.
No, sir. No, sir. What is the mass associated with magnesium 24?
23.99.
There you go.
So don't.
Don't round. last
I
night.
had too much doing.
Mm-hmm.
Stressing me out.
Didn't I tell you? I warned you from jump. Okay? Now, last few things. We're continuing to classify molecules. Some things that, when we look at molecules, there are more things that you can figure out based on the composition of the molecules themselves. Alright? So we have diatomic molecules. Diatomic molecules simply means that you have two types of atoms in this molecule. Triatomic, that means you have three atoms in this molecule. Polyatomic means you have four or more. Okay, so it has to be more than three.
So what is a diatomic molecule?
No. In total,
Oh,
how
total.
many atoms?
Okay, that's a triatomic.
Triatomic, good. Now you have homoatomic molecules. Homoatomic means a molecule means that you have all the atoms present are all the same. Heteroatomic molecules, that means you have different atoms in there. Did we get that? All right. Let's take some questions then. Elizabeth, A. We are going to classify these as diatomic, triatomic, polyatomic, homoatomic, and heteroatomic. So what is A? A can be two.
What's the atomic?
First off, don't you see an H there? Sabrina, don't you see an H right there? Sabrina, don't you see an H right there?
Yeah.
There you go, see? You know what you done, what you talking about, Tatiana?
Y'all got different.
Elizabeth, tell me.
A is diatomic
Diatomic,
and
heteroatomic, right? Did we get that? All right, so B goes to Claribel.
B is triatomic
Triatomic,
and it's heteroatomic.
heteroatomic, good. Denise,
polyatomic,
polyatomic and
homoatomic.
homoatomic. Noreen,
It's polyatomic.
polyatomic and
Hetero.
heteroatomic. Very good, that's what I got you. Did we get that? You see? I did fix it. Okay, let's see who's next. Okay, we got 3 minutes. I'm gonna give you